So let's do a specific example. Suppose f of x equals 1 over x squared, g of x equals square root of x. Find f compose g and g compose f and the domain of each. So they want you to write out the formula for f compose g, the formula for g compose f, and find the domain for each one. So f compose g of x equals f of g of x. F is 1 over x squared, so I get 1 over the g of x squared, which is 1 over square root of x squared. Notice I didn't simplify it. Find the domain before simplifying. So because it's square root, I have to have x greater than or equal to 0. But I can't divide by 0, so I need x strictly greater than 0. Right, so I wrote all that out. Okay. So the domain of f compose g then is open paren 0, comma, infinity, close paren. Right? The interval from 0 to infinity, not including 0. It's that simple. I didn't have to worry about all those little boxes on the previous page. Then you should simplify this expression for your final answer. And that would simplify as 1 over x. Okay? So f compose g of x equals 1 over x with x greater than 0. The x greater than 0 is part of the definition of the function. So that's why I put that in there. Because 1 over x, normally 1 over x would be defined for x not equal to 0. So you'd also have to throw in x less than 0, right? But not for these. So g compose f, composing the other direction, is g of f of x. The g function is the square root function. So it's the square root of f of x, which is the square root of 1 over x squared. Now before you simplify, find the domain. Need 1 over x squared greater than or equal to 0 because of the square root, which is always true as long as x does not equal 0. So the only restriction here is x is not equal to 0. So I wrote that in interval notation there. Open paren, negative infinity, 0, close paren, union, open paren, 0, comma, infinity, close paren, right? Now you simplify the expression and you get 1 over the absolute value of x. Here you actually need the absolute value of x because the domain includes negative numbers. And think about negative 2. If I plug negative 2 in here for x, I get 2 squared is 4. I get 1 over square root of 4, which is 1/2. Right? X was negative 2, but this value is 1/2, so I need the absolute value to make that negative 2 positive. So compare these two. They're kind of close to, they're similar, but they're not quite the same. This first one, we require that x is positive. So we wouldn't need absolute value there because x has to be positive. The second one, we don't require x is positive. We just require that it not equal 0. And that's because the thing inside the square root is a quantity squared. So it can't be negative, right? And so then we need the absolute values out here. But the restriction here is different. You can have negative x's. It's this one here. Now the reason I didn't write that right next to it is because, like x not equal to 0 right next to it, is because it's clear from looking at it that x isn't 0 because we didn't lose that information like we did down here. Here we lost the information that x can't be negative. when we reduced, right?